So, you know this, or maybe you don't know this. For example, if I have something like sine 20 degrees plus 30 degrees, that is not what? Oh, no, it is sine 50. No, don't. Yeah. No, don't worry, it's still sine 50. I'm not changing maths that much. But it's not sine 20 plus sine 30. So what we want is ways to calculate compound angles. That's what this is. That's a compound. Okay? And in fact, we have rules to do this. Now, in the past I did the proof of these rules in class, but these proofs aren't going to be on the exam, and the proof is not that difficult. It uses the sine and it uses the cosine rule. So I'll just give you the results, because in fact I think a lot of you have seen these formulas before. So I'll write them down, you can tell me if you've seen them before. So the first rule is, if I want what I just said in the question, or my example I mean, is sine A plus B. So it's not quite sine A plus sine B, but it's not too far away from that. It's actually sine A. Very good, Sean, go on. Good, yeah. So it's not quite sine A plus sine B, but, you know, not too far away. No, this is new. Well, this is new for this class. But I said maybe you saw it in high school. No, this is new. But is Sean the only one that's seen this?
I don't remember anything about high school.
Alright. I'll do the proof then real quick. You don't need to write the proof down, just so you can see the proof. Yeah? Can I scroll down? Yeah? Okay. Let's try and draw the proof. Oh my goodness, how do I do this proof? Let me see if I remember. Okay, I draw a circle, and this circle. I thought you said you don't like those jelly beans. Alright, if we can focus on this now. I'll try and do these in different colours if I can. Okay, can you see these here? Yeah. So this angle here I'll call A, and this angle here I'll call B. And by the way, the radius of this circle here is 1. Okay, so I'll just make two triangles here if you can see them. The green one and the red one there. Can you all see this okay? Yep, and the red one here. That's kind of on top there. Right, so what I'll do is I'll just use Pythagoras on both of these. So if this, from your physics, if this has a hypotenuse of 1, how big is this side? If I resolve it. No. Here to here. 1 cos A. Let's not forget our basic physics and trigonometry. And how big is this side? Sine A. 1 sine A. And for this triangle, the red one, you have a cos B. And this side? Sine B. Yes? Yeah. Now what I really want to know is this distance here. Because that's how the proof goes. So we need to calculate this distance here. So, if I imagine, please, the jelly beans are so distracting. If I draw another triangle here in blue, I can use Pythagoras to get this side, which I'll call x. So I can say x squared equals, now how big is this? Well, that will be cos A minus cos B. Because that's cos A and cos B, so the difference is that squared. And you can see what's going to happen on the other side. It's going to be sine A minus sine B squared. Yeah? Right, so if I expand that, that would be x squared equals
Sine B minus sine A.
Okay, well it doesn't matter actually, because when I expand it I'll get the same thing. But I'll change it anyways, thank you. B and A. So that would be cos squared A plus cos squared B minus 2 cos A cos B. And then plus sine squared A sine squared B minus 2 sine A sine B. But what's cos squared plus sine squared? 1. And then this is another 1. So in total it'll be 2 minus 2 cos A cos B minus 2 sine A sine B. Okay, which I'll just take the 2 out. 2. Well, no, I'll leave it like that for the moment. Now, another way I can get the x is by using the cosine rule. If I look at this triangle. See this one here? So, cosine rule says x squared equals 1 squared plus 1 squared minus twice 1 cos this angle here. And what's this angle? This is angle. Yeah, well actually it depends if I... Well, it depends what I mean exactly by B. Did I say this is B or did I say the whole thing is B?
Just the top.
Oh, but the way I did this, it made it look like the whole thing was B. So the whole thing is B. So that angle there is B minus A. Okay, so then I get 2 minus 2 cos B minus A equals x squared. But I have a formula for x squared already. So I'm actually not proving the formula I just wrote down, I'm proving a later formula. Minus 2 sine A sine B. So you can cancel the 2 and divide by minus 2 and you get the formula cos B minus A equals cos B cos A plus sine B sine A. But of course the A and the B are just letters. You can swap the letters if you like in the formula. So normally you write like this: cos A minus B is cos A cos B minus sine A sine B, and that's the proof of what's going to be the next formula. I forget what the proof is for this one. It's something very similar to this what I just did there. So the second formula is cos A minus B. We're going to do that now. A little bit. Now, what do you do if there's a different sign? Not a big deal. For example, in the first formula, if it's sine A minus B, then it's sine A cos B minus sine B cos A. And in the second formula, if it's cos A plus B, then it's cos A cos B minus sine A sine B. Okay, so these, in fact, we have 4 formulas already. Yeah.
What is sine rule?
Well, sine rule?
Yeah.
What do you mean?
We learned it before.
Oh, sine A over A equals sine B over B equals sine C over C. You forgot it? Ah. Okay, so what will be the last formula I need here? Tan, yeah. Tan A plus B. That is tan A plus tan B over 1 minus tan A tan B. And if we had a tan A minus B, then we'd have tan A minus tan B over 1 plus tan A tan B. Okay, so these are our 6 compound angle formulas. And also, it's not a new formula, but I think it's good if I remind you of this formula, which we will use today, I think. Sine squared A plus cos squared A equals 1. That's just something to remember from a previous lesson, semester 1. It's useful for this lesson too. Yeah. Continue. So now that we have these formulas, let's see how we can use them. So the first thing, which they sometimes ask in the exam, is they ask you, without your calculator, calculate something like this, sine 15 degrees. And the only thing you're allowed to use are these two triangles. Where this is a 60, this is a 1, this is a 2, and this is a root 3. And then you can also use this triangle. That's a 30. That's a 45. 1, 1, root 2. You're allowed to use those two triangles, but you're not allowed to use your calculator. And for example, they would ask you in the exam, calculate sine 15 exactly. Is this wrong? 1, 2. I think this is right. This is right. Yeah. 1 plus 3 is 4. Yeah, it's right. Sine 15.
Sine 45.
Sine 60 minus 45, or sine 45 minus 30. Both will work. Let's go with sine 45 minus 30. So according to our rule, that's sine A cos B minus sine B cos A. Now, from our triangle, sine 45 is 1 over root 2. Cos 30 is root 3 over 2. Sine 30 is root 3 over 2. No, it's not. It's 1 over 2. And then cos 45 is 1 over root 2. So this is root 3 minus 1 over 2 root 2. And we should multiply the top and bottom by root 2. So this is root 2 times root 3 minus 1 over 2 root 2 root 2. 2 times 2 is 4. Times 2 is 8. So 8. Root 6 minus root 2. Now, if you take out your calculator, not you, and type in sine 15, see what you get.
I can do that as well. It's 4.
Huh? Oh, yeah, sorry, 4.
It's 0.
Yeah.
Teacher, how do we get the value? 2 squared 3, 1 squared 2.
These from the triangles.
Yeah.
You're allowed to use these.
How do we get the value?
You need to know them.
Like you need to memorize them?
Yeah. Dang. Memorizing sucks. come on. It's 6 numbers. It's not that bad. 1, 2, root 3, 1, 1, root 2. Did you not do these triangles in high school?
No, I mean, your drawing is a little bit awkward.
Wow.
Because 30 has to be there and 6 has to be there. This is kind of
No.
So this should be there.
Here!
Yeah.
No. No, I feel sorry for you. You must have had bad high school math teachers. Let me explain.
Your drawing is 60, and that's how 30 looks like that. How 30 is that big and 60 is
No, don't. That's just a scale
Not
issue.
important.
Yeah, it's not important. Thank you, Sean. It's not important. Do you know how to make this triangle? Have you not seen this? You draw this. Okay, 2, 2, 2.
Yes.
And then this is 60, 60, 60. And straight down the middle. So now this is 30, this is 60. And that's a 2, and that's a 1. And Pythagoras said that's a root 3.
Yeah. Yeah. Yeah.
Yeah, you can just draw it directly. No, I know you can. Never mind. Okay, continue.
Yeah.
Yep.
What? No.
You're writing this down. This is, I think, question 1 that I just did. Yeah. 2. Yeah? No. Okay. Oh, you all look so sleepy. What class have you got after mine? Lunch and then physics. And then after physics?
We don't have to draft today, right?
1 or 2 hours of chemistry.
2 hours.
2 hours?
What's wrong?
Thank you.
Don't make me scared.
I didn't do anything at all.
Lee, what's taking so long? Come on.
Because I draw the triangle. Okay.
Yeah? Continue?
Yeah.
Yeah, okay. Now, just before we continue, just a quick check of your vocabulary. So, we'll start here in 0. So this is 90, 180, 270. Angles which are here, less than 90, what do we call these?
Acute?
Yeah. Stop, come on. What do we call the angles which are between 90 and 180? Obtuse. And angles which are
The rest.
more than one, the rest, yeah. What are these ones called?
The rest.
It doesn't actually. That's an or.
Rest.
Rest, no. The rest, no.
One more. Rest. Refusal reflex.
Reflex. Yeah, I thought you'd knew that.
No, I never thought that. So teacher, reflex is...
It's actually 180, more than 180, basically. Yeah, all of these here is reflex. And obtuse is this one, and acute is this one there. Yeah, got that? Are these new words? New or? Okay, next. So in this circle, The other thing which you may already know from high school is that in this here, actually just to give you more vocabulary, this is called quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, sine, cos and tan, all of them are always positive. So sine of an acute, cos of an acute, tan of an acute is always positive. So all of them are positive. In the second quadrant, between 90 and 180, only sine is positive and cos and tan will be negative. So for example, sine of 100 is positive, cos of 100 is negative, tan of 100 is negative. So only the sine is positive. In quadrant 3, only the tan is positive, and in quadrant 4, only the cos is positive. But I think you've seen this in high school. Yeah? A-S-T-C. Yeah, what did you learn in school to remember them?
All
science teachers. Crazy? Are you sure? That doesn't sound profane enough. What? All science teachers suck? No, that's not right. S-A-C-T? No. Anyways, I'll tell you the one I learned. All students, don't worry, it's fine, take care. Yeah.
Oh, gosh.
Monica, you're
that would be better.
so perverted. Please. Like, I mean, there's so many other C words like coffee and chocolate. You jump straight to class A drugs. All students take cocaine. Come on. Okay, so you've seen this before. Yep. Right, so now let's see how we can use this for a problem. Can I scroll down? Okay, so let's say I tell you, I'll do something like that one. Tan A equals 3 over 4. Tan B equals 5 over 12. A and B are both acute. Find, let's go with find cos A minus B. Exactly. And just before I start, what they don't want in the exam is this. Yes, true, you could find A here, and true, you could find B here, and put both of them into this, but that's not the way they want you to do it. And in fact, in the exam, they might even say in the question, do not find A or B. Which seems a bit odd, because if this was a physics question, it'd be perfectly fine to get angle A here, get angle B here, and then get cos A minus B, but not for maths, okay? So how can we do this? There's a couple of ways. Yeah, we'll just draw a quick picture here. So this is 3, this is 4, and this is 5. This is 5, this is 12, and this is 13. So it might seem like, oh, you're finished. Cos A minus B equals, now this one here is A and this one here is B. So that's cos A, which is 4 over 5. Cos B, which is 12 over 13. Plus sin A, which is 3 over 5. Sin B, which is 5 over 13. And you might think, done, but not quite. There is a small problem. It isn't a problem in this example, but it is usually a problem in the exam. It's actually the case that we don't know the signs here. Like, there's a plus minus issue here that we don't actually know. Now, I'll do another example where this becomes a bit clearer. but technically we don't know if this is a plus or a minus, because remember, yeah, that's what I'm going to say, but we haven't used the fact that I told you in the question A and B are both acute, which is what makes me decide on if it's a plus or a minus. But the reason for this is in the triangle here, I actually could have had something weird like -3 over -4, and I couldn't tell a difference. The triangle be in a different quadrant. So there actually is a plus minus on these. But because I say that they're both acute, that A and B are both acute, it means sine, cos and tan of angle A and B are all positive. So it means I choose positive for all of these, and now there's no problem. So this is a 65 down below, and what's that, a 48 plus a 15, 58, 73? No, that's totally wrong. What am I saying? 48 plus 15, isn't it? 63, not 73. Now let's do another example, but when it's not as clear as this. Okay, can I?
No.
Not yet? Okay. Now, I don't mind drawing the triangles, but there is another way to do this one. Let's do... Actually, let's do this one again, except I'll ask you for something different. Let's do something like this, and let's just make them up. By the way, which quadrant is A minus B in? Well, not necessarily. It could be in the first or the fourth quadrant, because these are the quadrants where cos is positive. You see, even though A and B are acute, if B was bigger than A, which it could be, then it would actually be in the negative, so it'd be in the fourth quadrant. But it's fine because the cos is still positive there.
A is bigger.
Yeah, because you worked out the A and B. But I could have easily have done it the other way around. I could have just changed the question. Like, you realise because all of these are positive, if I called this one B and this one A, you would get the same answer. Okay, next one. So let's do this one. Let's say sine A is 4 over 5, and let's say cos B is 12 over 13. And I want you to find, let's say, tan A minus B. And let's say A is in and B is in. No, I want to use acute and obtuse. A is obtuse and B is, yeah, go on, reflexive. And I want to find tan A minus B. Now, you could draw the triangles here, that's fine. You draw your triangle and you draw your triangle, but there is another way to do this one, because you can actually also say sine squared A plus cos squared A equals 1. So that means cos A would be square root 1 minus 16 over 25, which is 3 over 5. But you would know that from looking at the triangle anyways. But what's interesting about this method is it makes it clearer the problem with the sine. Because using this method, clearly you can see that there's actually two answers here, plus or minus. So this clearly shows that there is a sine issue here. Yeah, there's a plus minus issue here. Now, I kind of wasn't being 100% accurate when I said there's a plus minus on all of these in the previous example, because Oh no, sorry, I was. Disregard. Okay, so continuing here, there's a plus minus on this. Likewise, for sine B, there's also a plus minus issue, and that will be 5 over 13, looking at this triangle. This is a 12, this is a 5, and this is a 13. There isn't a plus minus issue here because we know that this is a plus, and there isn't a plus minus issue here because we know this is a plus. Right, so let's look at our formula. Tan A minus B. That's tan A, which is 3 over 4. Yeah, or sine A over cos A, if you want, like that. But there's a plus minus issue here. Isn't there?
Teacher, why is cos B doesn't have plus minus issue?
Oh, because I give it to you in the question. I tell you cos B is 12 over 13. So it can't be minus 12 over 13 if I'm telling you it is 12 over 13. Why do you look shocked by this?
Why not? Why not minus 12 over minus?
Well, if I tell you x is 3, and you reply, why can't x be minus 3, what am I supposed to say to you? Do you get what I'm saying?
Okay.
No, I kind of understand what you're saying, but if you really think about it, if I said x is 3 and then you say, why can't it be minus 3, what am I supposed to say back? If you figure out an answer, that's what you need to tell yourself, okay? So cos B is 12 over 13 because I tell you it's 12 over 13 in the question, not minus 12 over 13. Right, so tan A minus B, on the top, that will be 3 over 4. Yeah, right. Minus 5 over 12. But there's plus minus issues here. Plus minus, plus minus. And then on the bottom, it's 1 minus tan A. What did I do wrong? No, that's a plus. Yeah. And again, there's a plus minus and there's a plus minus here. Now, if we think about the circle, we can figure out if it's a plus or a minus. So I tell you A is obtuse. So A must be here. So tan A, positive or negative?
No.
Negative. Okay, so that sorts this guy out. He must be a minus and he must be a minus. Okay, what about the B? Well, I tell you B is reflex, so actually it could be here or here. But you can pick which one is right. Which one is it? Where's the B? No, it's in the fourth quadrant. Because I tell you cos B is positive. And the only quadrant where cos B can be positive is in the last quadrant. So that's where tan must be. Yeah. So, tan B, is it positive or is it negative? Negative. It's in the fourth quadrant. Only cos is positive here. ASTC. Yeah. So, again, in fact, we choose negative here and negative here. So we have minus 3/4 minus 5/12 over 1 minus 15 over 48. Yes.
Sine A over sine B equals minus 4 over 4.
Yeah, but sine A over cos A for tan A.
Yeah. Sine A is 4 over 5.
Sine A is 4 over 5.
Sine B.
Cos A
Cos A is minus
is 3
over 5.
Yeah.
So sine A over cosine A equals minus 4 over 6.
Oh, I drew my triangle wrong. I should have put the 4 here and the 3 here. Hang on. What's the easiest way to fix this now?
Use cos A.
I mean, 4/5
Yeah, but
3/5 is
this
4/3, not 3/5.
Oh, I know.
Yeah.
Shh. Let me think. I'll just change this to 3. I think that'll fix everything.
Yeah.
Sine A, cos B, 1. Oh, that's a tan. Yeah, that fixes everything, doesn't it? I think everything's fine. Just change that to 3 in the question. Okay. 12, 9, 5 minus 9, minus 4/12, minus a third? What?
That's negative cos A, 4/5.
Yeah.
Cos A is 4/5, where?
Plus 2/5.
Yeah.
Yeah.
Yeah, that's what I meant. Oh, 4/5. Yeah, but that doesn't change anything here, does it? 3/4,
Yeah.
5/12, 3/4, 5/12, yeah. Is this minus a third on the top?
Yeah.
Okay, 48, 63/48? No, it's not.
Yeah.
Yeah.
It is 63/48, is it?
Yeah.
Ah. Is this the final answer? Yeah, okay. So, because tan A minus B is negative, which quadrant could it be in?
No, the second and fourth.
Oh, students take care. So it could be in the second quadrant or the fourth quadrant. This is negative. Yeah. So these questions are a little bit tricky, but it's tricky just because you have to think about which quadrant you're in.
Teacher,
Yeah.
what is the point of doing cos and like this?
I don't know really. I didn't need it.
Okay.
I guess my point was I wanted to show you that the plus minus can come about because of the square root. But you're right, there was very little point in doing this. In fact, some may say pointless. But I wouldn't say pointless because you learned something about plus and minus. So. Yeah? Now, one more example that makes compound angles useful.
Teacher, how do we decide plus and minus again?
Oh, dude, you just asked me to repeat the whole question.
ASTC.
Yeah, the ASTC.
So tan A is minus y.
I tell you in the question sine A is 3/5. So which quadrant could angle A be in?
2.
First two, right?
Only 2. Make me say obtuse.
And then, wait, we're one piece of information at a time. So if I just tell you sine A is 3/5, it can be in the first or second quadrant.
Yeah.
Now, if I tell you A is obtuse as well, then we can only be in the second quadrant. So the A angle is in the second quadrant. So that means cos and tan of this angle should be negative, because only sine can be positive in that quadrant. Now let's look at the B. I tell you cos B is a positive number. Which quadrant are we in?
1 and 4.
1 and 4. But I also tell you B is reflex, so we're only in quadrant 4, which means although cos is positive in this quadrant, I know that sine and tan of this B angle will be negative. Happy now? Okay, continue. All right. Next one. I'll just make up one. Okay, are you looking? So, for this problem, what's interesting we don't have a way to add these together because sine is sine, cos is cos. We can't combine them. They're separate. Sean, are you listening?
Yeah.
Sine A and cos A, we can't add them together because they're two different things. But what's useful about the compound angle formula is it gives us a way to add these two different functions together. So watch this trick. What you do first is you square this, and square root it, and you get 5. Okay? So the first thing to do is you take out a 5, and you're left with 3/5 sine A plus 4/5 cos A. Okay, and now we'll just do a little bit of a rearranging here. You change this into 5 sine A times 3/5 plus 4/5 times cos A, like this. Now, you might say, well, what's the point in doing that? Well, just draw a quick triangle here. This side is 5. This side here is 3, and this side here is 4. What's this angle, please? Can you just tell me that angle? Tan inverse 4 over 3.
37 over 4.
Give me a couple of decimal places. 53 point...
13.
One more.
1.
Oh, okay, 53.13 degrees.
But this doesn't say is equal to 3 over.
Oh no, this has nothing to do with A, angle A. What I'm doing is a little trick here. This is 3 over 5. But another way of writing 3 over 5 is by writing it as cos 53.13 degrees. Cos 53.13 degrees is the same thing as 3 over 5, is it not?
Yes.
Yeah. Plus, and what's another way of writing 4/5 as I could write it as sine 53.13 degrees cos A. Now you might be thinking, well, that was an awful lot of work. I mean, all I did was take a 5 out. What was the point in doing that? And now with the 5 on the outside and the fractions I'm left with on the inside, all I did was to change them into a cos and a sine. But the reason for doing that is now this looks like a compound angle formula. Sine A cos B plus sine B cos A. That's sine A plus B. Or in other words, that's 5 sine A plus 53.13 degrees. So I've taken two different functions, a sine and a cos, and I've combined them into one single function. Now why is that useful? Well, because if I told you to solve something like this, 3 sine A plus 4 cos A equal to, I don't know, 2, you can't. Until today there was no way to solve that. Because if you try to simplify it by dividing by cos, you'll get a tan here, but then you'll get a secant here. However, if you change this into 5 sine A plus 53.13 degrees equals 2, now you can solve it. We did this in semester 1. You divide by 5, you do the inverse, it has 2 answers, and so on. So the compound angle is a very nice way of combining sine and cos into either sine or a cos. Yeah? Okay, so this is a useful trick. You should write this example down. Yeah?
How do you arrange 5, 3, and 4? I mean, if you arrange...
You have a lot of flexibility here. There's more than one answer. So you could have flipped it the other way.
Yeah.
You could put your 3 here and your 4 here. That would change these into sine and cos. So you'd have a sine and a cos, which means you would have a cos A minus B formula. It will be the same thing.
It is the same thing.
Yeah. You'll have a different angle. You won't have 53.13. Okay, did you write that down? Yeah. Great, we've got 5 minutes of practicing. No, is that clock slow? Now, hang on, let me check a trustworthy source.
50.
I'm checking a trustworthy source. It's it is exactly 50. Yeah.
What?
Oh, sorry. Write this down and then we'll finish.
Can you tell me what is the purpose for doing like square root form?
Oh, the 5.
Yeah.
Oh yeah, the only purpose of 5 was to make fractions here. Why 5? Because I want to make sure the fractions I get represent actual triangles.
Oh, okay.
So using Pythagoras, I'm guaranteed that the fractions here will be real triangles. Like obviously something like 112 is not a triangle. You would need like 1 root 2. So this guarantees I can form triangles on the next line.
So hard.
Yeah, we're off.
So difficult, teacher.
What's so difficult? Being awake?
I do not understand the second sentence. Sine, cosine, minus.
Jerry, we'll do them in the tutorial this week. We'll make the last maths class a tutorial this week. Whenever the last maths class is. Yes. Can I close this?
Are we gonna the math course work together in the assessment report?
In the assessment report, we're going to work on maths coursework. Yeah.
What about social?
So what you're asking me?
Yeah.
Yeah.
We're gonna see it.
Oh yeah, everybody's finished more or less with task 1, so we can talk about task 2.
You know,
I did some task 2 and I put down the Excel, but it's really, yeah.
We'll deal with that in assessment support.
Oh yeah, I book it on.